Just a minute. All right, man.
All right, Alex.
Take care, man. I'll see you. Just when I wanted to record the video, the UPS guy came in. Here we have an iPad 12.9 second gen that came in for no power. We already disassembled the board and I removed the black shield that goes on the front here. Now, the first thing that we did was plug the charging cable, and we noticed that the charging station is charging at 5 volts, 0.6 amps. Even now, we do not have a battery connected. And on iPads, if we do not have a battery connected, then amp draw should be 0. But right now we have 0.6. I do not know if you can see it, but you're going to have to trust me, okay? 0.6. 5 volts at 0.6. That's not good. It's very possible that we have a short circuit on the board, and that's why the charging station is showing 0.6 amps. Let's take a quick look. Quick visual inspection. And the tablet was not open before. This is the second gen. And we had to tell the customer about the possible risks opening the screen, because screens for the second gen 12.9 are expensive right now because of shortage. The customer okayed the repair and the risks involved. We were able to remove the screen without any issues, but we always tell the customer. Right now the tablet was not open before. Everything is mint, everything looks good inside. I'm looking for possibly a blown component or discolored component or anything obvious that we may find. Now look at the board. It looks perfect. Usually, most of the times, we cannot tell by just looking at the board. Right now, since we cannot tell what's going on, you know what, let me check the battery connector from the back, and it looks good. And there are no components on back of the board, so we do not have to worry. Those SMD components almost always, actually not almost always, always, they are fine. I never had to deal with those components, not once. That's the charging Flux. And nothing, I do not see anything obvious. We can measure around the PMIC and see if we have a short. Very common on iPads. I've done a lot of videos about a short circuit around the PMIC, meter and diode mode. We're gonna randomly measure caps. We are good. We're good. Yeah, nothing obvious. And we can quickly go over this diode, this one here, and just randomly measure caps. Inductor, inductor, diode, and nothing. Nothing is standing out as being faulty or short. So what on the board is drawing 0.6 amps? That's the question. We do not have a battery connected. Let me plug the charging cable, and we're going to monitor the board under a thermal camera and see if there's anything obvious. We're not going to inject any voltage because we cannot find any short circuit on the board. So where would we inject voltage? Something is using the amps. And if there's anything on the board using the amps, then we must have something hot. And I do see something hot right in the center. Let me grab a plastic spudger. Right now I'm pointing, you're looking at the thermal camera, but I'm looking at the thermal camera and the microscope, and I can see the S47 chip getting hot. And if I feel it, oh yeah, very hot, very hot. 149 degrees Fahrenheit. 153, 154. The chip is getting abnormally hot. And to be honest, I never had to deal with this chip before. This, I believe, is the backlight IC, S47. But I never had to replace this chip, not even once. Is it possible that the chip went short by itself? Anything is possible. Right now the chip is protected, as you can see, protected from here, from here, from here. So we're not going to be able to desolder the chip unless we remove this underfill or this glue from the sides. And how do we get rid of the glue? We have to apply a little bit of hot air, maybe 200 degrees, and we have to scrape off the glue on the edges. What happens if we do not remove the glue and we attempted to just apply hot air and remove the chip with the tweezer? We're gonna end up taking that component along with it, taking that component, that one and that one, anything that attaches to that glue. Because when we apply hot air here, solder on all those components and all this area will liquefy. So by trying to remove that chip with the tweezer, we're gonna pull all those components that attaches with that glue. We have to think outside the box. We're gonna put the board in the board holder like this. That's one heavy board holder. You can also find it and purchase this board holder off our site. We have multiple board holders that you can buy, and I use this one a lot. I've had it for what, like 4 or 5 years. It's metal and very rugged, very durable, and very heavy. And it looks like we're gonna have a hard time removing this underfill because it's hard like a rock. Let me up my temperature. Some glue is easy to remove and others are hard. I just want to separate the chip from other components. And it's very hard not to scratch the board, but that's okay. We're gonna mask it at the end, apply UV mask. We did not scratch this area, but we did here. And finally, we have this side here. Okay, so we're good. We are clear. Let's up our temperature and desolder the chip. And then we're gonna monitor to see if the charging station is still drawing 0.6 amps after removing the chip. If not, then we can consider this tablet fixed. Now, we do not really need to clean because that's not a BGA chip. And we do not have any underfill under the chip. And there is no reason why we would have any underfill under the chip. See, we're gonna have to mask that scratched area because if we do not and we apply solder on those pads, then they may bridge. This is likely ground and those are not ground. And that's not good. We have to separate the ground from shorten out anything else on the board. But the solution is easy. Before we test to see if we still have a 0.6 amp draw, let's just go over this quick. And we're gonna apply our UV light. And while we are applying UV light, why not plug the charging cable and see if we still have a 0.6 amp draw? Why not do 2-in-1? Hit two birds with one stone. Plug the charging cable. The charging cable is in and we still have 0.6 amp draw. We still have 0.6 amp draw, so we fixed nothing. That's okay. When going gets tough, tough gets going, right? Or when tough gets going, going gets tough. Or when going gets tough, tough gets going. Any way you put it, it works. Because we had one viewer, he said that I said it backwards. It works both ways. Okay, so our mask is good. And we do not have any exposed copper, possibly ground. Let's wait until the board cools down a bit. And then we're gonna plug the charging cable and monitor the board under a thermal camera again. See how that UV mask, it covered the exposed line? Beautiful. That's high quality UV mask. Solid like a rock. Let's go ahead and plug the charging cable. Charging cable is plugged in. And we're gonna go over to our thermal camera and look at the board. Now something else is getting hot on the board. That was not the case before, but something else right here. And that's a power IC right here. This guy is getting hot. 00010. I do not know if we have that chip in stock, but let's go ahead and remove it and see if that's the problem. First we remove and then we worry about replacing. And pin number 1 is right here. So let's put a dot right here. A silver dot. And let's remove the chip. This one is a BGA chip, so it has solder balls under it. We're gonna have to clear those solder bridges under that chip that we just removed. Right now it's almost 6 p.m. and this one is the last repair for the day. If the problem is the chip, I hope that we have the chip in stock. We have a lot of different types of chips for iPads, and I do not really know if we have this one or not. If we do not, then we're gonna have to finish this iPad at another time. For the time being, let's get rid of the glare. Very nice. I just want to make sure no two solder balls are bridging. And let's go ahead and test. We're going to plug the charging cable. And do we still have 0.6 amp draw on the tablet? And we do not. Black. That's perfect. Okay, so we do not have the chip in stock. We do have the 89, but I do not know if the 89 will work. Let me just look it up quickly online. The 00090 is for iPad Pro 9.7 and 12.9 second gen. I do not have that chip in stock, and we're gonna have to order it to finish the video. It's time to go home. Let me just put the backlight chip back on. All right, and we're done. We put the backlight chip back on the board, and we figured it out. The problem is the 90 chip. We do not have it in stock. We're gonna order it and wait until we get it. That's it. We're gonna end the video right here. I hope you enjoyed it. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.